Hi guys, this is a new video to present you the latest version of my glsl raytracer. As you may have noticed, I'm talking because I think that it's better for you to have real-time comments on the images. So I hope you will enjoy these comments. I hope it will be clear enough for you, and I'm just waiting for your feedbacks and comments on what I should do, what I shouldn't do, and what you expect me to do in the next videos. So that's all for the first part of my video. Now in this second part, I'd like to talk about the project itself. So first aspect and first update is the camera system. The old one was difficult to use. I just couldn't do what I wanted to do with it. I couldn't check small details. I couldn't walk around, go behind a primitive like I'm doing right now, and I wasn't happy. So I removed everything of the old camera system code. I deleted everything, and this is the new one. It doesn't work perfectly because I still have some issues with adjusting the mouse with the viewport because SDOL 1.3 didn't implemented the warp mouse function. So I tried to fix that by using another windowing library, but I don't know. For now, it's not a major issue, and I can deal with that. I can deal with that, so it's okay. Now, second point, I've been working a lot on interactivity between the user and the application. So what I've implemented and what I've been working on is this interaction and also the interaction between GPU and CPU. So the shaders and the application itself. So now I've implemented a new version of the add, delete, and edit primitives. So I just have to show you. Let's just put some objects, add some objects on this wall, or no, on the roof. So as you can see, I've added 10 small spheres. They are placed depending on the view direction and the normal vector of the point I've clicked on. So this means that I had to implement functions to pick primitives to get the result, to get the intersection point between primitive and the ray direction, and I've implemented functions to add directly primitive to the scene. So these are 10 spheres. They are placed on a kind of a sine path, and just to show you that I can add dynamically objects in the scene, so I can add them wherever I want. Here, there, on the floor, there, on the roof, another one. So, well, it's more funny than anything else, but I'm kind of happy it works kind of perfectly. Well, not perfectly, but it works, and I'm happy with that. So I can also show you how I can delete primitives. So I can delete the roof, I can delete this wall, I can delete another wall like that one, and then the scene is clear and I can just walk around, and I deleted 3 primitives and it's okay. Everything is okay. The next the next new feature, I don't know if it's really a new feature, but I've implemented a completely new way of doing it, is editing some attributes from objects in the scene. So basically I can pick a primitive and modify it directly on the GPU and modify its attributes. So let's take this small sphere. The functionality I've implemented, just to show you the feature, is changing the color of the objects the object selected to gray. So if I click on it up, it turns to gray. I can do it with the big sphere, I can do it with other small spheres, I can do it wherever I want. So, well, it can look stupid for this kind of application, but I already see how it could be used in video games and how funny it can be and how real interaction I could have with the scene by using that. So let's see what I will do with that. The functionality is implemented, I just have to use it now. So this is it for the first point. Well, no, the second point, sorry. And as you can see, everything works perfectly and I'm happy with it. So now the third point, sorry, of this video. The third point of this video is post-treatment of the scene. Basically is just getting the frame buffer object from OpenGL, sorry, and you're having a second shader to modify the rendered scene. So what I've implemented and I'm gonna show you is a bloom effect, kind of a bloom effect. Well, I like it. It works. I don't know if I can really call that bloom effect, but it's what I've understood of bloom effects. Kind of a blur actually, but I don't know. It looks nice and just a nice sample of how I can use and how it can be used. How this post treatment can be used in my project. So I'm kind of happy with it. The other thing, but this is not anymore post-treatment. I modified the first shader to render the scene as with toon rendering. So here it is. As you can see, there are there is a special lightning with steps that we can see like in cartoons, and there is an edge detection, as you can see, and well, it's nice and it was not that difficult to implement. I think it's even easier than on a regular rendering application, because I just have to for the edges I'm talking. I just need to calculate the dot product of the ray direction and of the ray colliding on the object and the normal of this point. So if this dot product is equal to 0, I know that it is an edge and that I have to render it in black. So it's kind of easy. And now the last feature that was still more about playing with the old features than anything else is I implemented some of this bloom on the cartoon rendering. So this is how it looks like. Well, it's nice, and it was just the last image I wanted to show you before the end of the video. So I hope you enjoyed it, because it took me a lot of time, but I really enjoyed doing this video, and see you in the next video.